We're looking at finishing up our graphing linear equations notes. So this is part 2. So this is review. We are assuming that you learned all of this in an Algebra 1 class, in an algebra class in middle school already to get you ready for Algebra 1. So standard form is kind of the weird form. So slope-intercept form is great because you can see the slope, you can see the y-intercept. That makes sense in terms of what the graph looks like. Standard form is ax plus by equals c. A, b, and c are integers, and we tend to like it if a is not negative. So a is usually not negative. So it is usually positive, I guess would be a better way to say that, right? Let's change that. A is usually positive. I won't say always because I have seen it like work people have done where they've left it negative, but I've never seen a textbook leave it negative. So in the textbook, they always make it positive. So the only advantage to standard form is that it is very easy to type because you have integers. So you don't have to use anything fancy to do math typing and make fractions. So that's, I think, why we see it so much in textbooks. And if you're looking at word problems, sometimes standard form is really easy to write. So those are the two reasons I would use standard form. So one of the things that's easy to use standard form for is to find y-intercepts. So in order to find a y-intercept, think about how your y-intercept was always 0, comma a number. So if we have it as 0, comma b, right, that's our y-intercept, 0, comma b. Let's think about how the x is the first letter, or the first coordinate in an ordered pair, and the b would correspond to the y. So to find an x-intercept, what we really want to key in on here is that my x is 0 every time I have a y-intercept. And so to find a y-intercept, I could let x equal 0 and solve. So standard form kind of lends itself to easily finding intercepts. And I know in slope-intercept form, you can always find a y-intercept, right? But finding it for this kind is pretty easy. It's just a quick step. To find the x-intercept, well, if it's on the x-axis, that means your y must be 0. So we are going to let y equal 0 and solve. And these are the same steps that we use even if we're not looking at a linear equation, even when we're looking at a much more complicated graph later on, even in pre-calculus, even in calculus, we still use this idea. So these are really, really important concepts here. So if I want to find a y-intercept, I let x equal 0. If I want to find an x-intercept, I let y equal 0. And now we're going to practice it a little bit. So let me go ahead and scroll up here and erase. I had left my little screen on, so you're looking at my ceiling, so that was not super helpful, but I'm not restarting this video. It's just going to be what it is. So on this one, I want to first find my x-intercept. So to find, and I'm only doing the x one first just because x comes before y in the alphabet, not because you have to. So remember, we're going to let our y equal 0. Or sorry, let y equal 0. Yes, I said that right. That means we have negative 3x plus 5 times, instead of y, I want to have 0, and then equals 30. So 5 times 0 is just 0. If that's a 0, it's gone from my equation. I'm left with negative 3x equals 30. And all I do is divide both sides by negative 3. And then x is equal to negative 10. So my x-intercept is negative 10, comma 0. So remember, ordered pairs are x, comma y. My x was negative 10. I let my y be 0. Okay, so for the second part of this, so to find my y-intercept, I want to let my x equal 0. And so that means I'm going to have negative 3 times 0 plus 5y equals 30. Again, we multiply something by 0, it just zeroes out. It's not there anymore. Adding 0 to 5y doesn't change the value. So 5y equals 30. Divide both sides by 5. and so y is equal to 6, and my y-intercept would be 0, comma 6. So again, I let x equal 0, I solved and got y equals 6. Ordered pairs are x comma y. So make sure that you go back and write it as an ordered pair. Okay, next one, same steps, and I'm going to just divide it up again. I know I don't need to write this every time, but these are our notes. Sometimes I write extra details on my notes so that I can remember what I did later on. To find the x-intercept, let y equal 0. This is a trickier one. That means we have 0 equals 1/4 x plus 6. So if I'm getting the x by itself, x is being multiplied by a fraction, and I've got the plus 6. We always get rid of addition first, so subtract 6 on both sides. Negative 6 is equal to 1/4 times x. So if I want to cancel out a fraction, that means I should multiply both sides by the reciprocal. So I'm going to show that in green here. That means we're going to do a times 4 over 1 here, and a times 4 over 1 on this side. So when I multiply that, when I have 1/4 times 4 over 1, remember the way we multiply fractions is we multiply the numerators, we multiply the denominators. So if I have a 1/4 times a 4 over 1, multiply straight across, 1 times 4 is 4, 4 times 1 is 4, 4 divided by 4 is 1. So all of that work, what we're doing there is we're just really getting our x by itself. So this is just going to be x on this side. And I've proven it up on my scratch work. On the other side, well, 4 over 1 times negative 6 is just really 4 times negative 6, which is negative 24. And so my x-intercept is negative 24, comma 0. Okay, to find a y-intercept, this is already in slope-intercept form, right? If I have y equals 1/4 x plus 6, that's like y equals mx plus b. So I don't have to do any work to find my y-intercept. My y-intercept is right here. So I already know that my y-intercept is going to be 0, comma 6. It kind of works out nicely that the 6 is a b because they kind of look alike the way I'm writing them anyway. Just going to continue down here. And then we're going to graph those. Okay, so negative 10, 0. So negative 10, 0 would be my x-intercept. Maybe I should go back and label those really quick. So let's remember that this was my x-intercept. So that would be a negative 10. This one was my y-intercept, which is 0, 6. And then all I do is connect them. So just to kind of recap this a little bit, I know it's kind of big having this all on one page. We'll shrink it down. So basically what I did is that this was starting out in standard form. So we found our x-intercept, we found our y-intercept, and they were here and here. And then we graphed our x-intercept, we graphed our y-intercept, and we only have to have 2 points to create a line. So we connected them and we got that line. So the other way to graph this is I could go through and I could take that equation and I could solve it for y, right? I could add 3x on both sides, and then I could go through 3x plus 30, and I could divide it by 5 now. So there are other ways to graph this. If I am trying to get a really quick graph, often I like the intercept method, but the intercept method is only 2 points on the graph. If I'm trying to get a super accurate graph, that's when I would go with my slope-intercept form. So it depends on what you're doing. So on the second one, I was going to graph using intercepts also, but like this is kind of a crazy number. That's not going to graph very easily. So the fact that it was already in slope-intercept form and that my slope-intercept form is really easy to work with, that's actually what I'm going to do. So I'm going to start it out at 0, 6. So that's going to be right here. And then my slope is 1/4, which we know means up and right. So I want to go up 1 square, 4 to the right, up 1, 4 to the right. If you're having trouble counting, you should definitely talk to your teacher about that. and then I'm going to connect them. So now I want to really think about what that or that x-intercept means, negative 24, 0. So that means on my x-axis, I would have a point at negative 24, 0. So here's negative 10, negative 20, negative 24, 0 would be like way over here somewhere. And I can see if I kept connecting this line, that it could cross that point eventually, right? But that just requires really big graph paper. So I think it's good to have some practice solving maybe a more difficult equation with a fraction for my x-intercept and my y-intercept, but graphing with them doesn't always make sense. So we really want to think about the best way to graph sometimes. So the last one is one of my favorite forms of a line. Point slope form is super easy to write because all you need, oh, I need this right here. So for point slope form, all you need is the slope, and your slope is m, and any point on the line. I'm trying to write neater rather than faster, so hopefully that second line shows up a little bit better for you. So all you need is the slope, which is m, and any point on the line. In fact, I'm going to go back and fix it right now. All you need is the slope. So like m is our slope, right? And any point on the line. And the point on the line we're going to call x1, comma y1, which should look familiar from talking about the slope formula. And then if you have that slope, you have that point x1, comma y1, you have that ordered pair, then the equation for the line is y minus y1 equals m, parentheses, x minus x1. So the slope is being multiplied by this quantity x minus x1. It's kind of like our slope formula. So if I think about my slope formula, my m equals y, instead of writing y2 minus y1, I'm going to write y minus y1, so a y minus y and an x minus an x. It's like I've taken this denominator part, multiplied it on both sides to shift it over there. So that's really where this comes from. It comes from the slope formula, but it's just a super easy way to write an equation of a line. So remember, when we have a y and an x, those are the y and the x that are going to be in our equations. You can see that on this example down here. I'm just plugging in stuff for y1, for m, and for x1. So a big thing to notice here is because there is subtraction in the formula, I have a minus x1 here, but my x1 was actually positive. I have a minus y1 here, but my y1 is actually positive. And ordered pairs are x comma y, but here my y is coming first, so I have to like flip-flop them. I have to make sure I fix that when I put it in my ordered pair when I'm looking at that. So I want to identify my point on this, and I don't want to rearrange it. That means we're not solving for y. Do not solve for y. And the reason we don't want to do that is because we don't need to. I could see on that last one how the y-intercept, or sorry, it was the x-intercept, was a very inconvenient number. And so using this method was more work. It didn't make sense. It was already in that slope-intercept form. But this one we don't already have in slope-intercept form. So to rewrite it, oh, now I can't get my graph to move. So to rewrite on this one, it's actually going to be more work. It's very easy to graph from point slope form. So if it says x minus x1, my x value is actually a positive 1. Y minus 2, my y value is a positive 2. So that means 1 comma 2, this point right here is a point on my line. The slope is the number in front of the parentheses, that's 3. And so a slope of 3 means I would make it into a 3 over 1, which is up and right. And so from this point, I want to go up 3 and 1 to the right, make a bunch of points on my line, and then I could go ahead and connect them. And my lines are getting a little bit less straight the more I make here. On our last problem, I want to do the same thing, graph using point slope form. If it says x plus 2, my x is actually a negative 2. Y minus 6, that means my y is a 6. So remember, we're like flip-flopping them and we're changing the sign. So So this is my y value here. The x is with my x, the y is with my y. And remember, ordered pairs have to be x comma y. And because of the minus signs in the formula, we've got a minus sign here, we've got a minus sign here. That means we're actually changing our sign. So be really careful about all those details. Our slope here is a negative 2/3. So that could mean negative on the top or the bottom. I prefer to put it in the numerator. I think it's easier to visualize and graph. That means I'm going down 2 and 3 to the right. So first we're going to start off at negative 2/6. So this is negative 2/6 because my point is negative 2/6. And then from that negative 2/6, I want to count down 2 over 3, down 2 over 3, down 2 over 3, as many times as I can. And remember, we can kind of reverse that, go up 2, 3 left to get to the points on the other side of the y-axis. And then I want to connect. Really got to figure out that line tool, but not super worried about it today. So this is just all those other forms of a line. So we looked at graphing y equals mx plus b before, and now we spent some time with point slope form. We spent some time with standard form, and we definitely we looked at the slope formula. Where's the slope formula at? Oh, that was the other day. We started with standard this time. All right, so this is part 2 of our notes. Make sure if you have any questions that you are asking your teacher in class.